Welcome back to AI Unraveled, your daily strategic briefing on the business impact of artificial intelligence. It is Monday, February 2nd, 2026. The viral story of the week has unraveled. Moltbook, the supposed social network for autonomous AI agents, has been exposed as a security nightmare and largely a hoax. Researchers found a database flaw that leaked 1.5 million API keys, while revealing that most of the agents were actually humans pulling the strings. But while digital agents are faking it, physical agents are making history. NASA has confirmed that the Perseverance rover just completed the first ever AI-planned drive on Mars, with Anthropic's Claude plotting the route across the red planet. Also today, SpaceX wants to launch 1 million flying data centers. Oracle is raising $50 billion to stay in the cloud race, and NVIDIA is officially outbidding Apple for the world's best chips. This podcast is created and produced by Etienne Newman, senior software engineer and passionate soccer dad from Canada. Now, let's unravel the news.
Welcome back to the Deep Dive. It is Monday, February 2nd, 2026. And I have to say, looking at the stack of stories we have on the desk today, it feels like we've officially crossed some kind of threshold.
It really does.
Usually, we spend our time sifting through these incremental updates, a new model here, a slightly faster chip there. But today feels different.
Yeah.
It feels like we're living in two completely divergent sci-fi novels at the exact same time.
It's a total split-screen reality. It's Monday, so, the industry is always chaotic, but the contrast today it's sharper than I think I've ever seen it.
Right. On the left side of your screen, you have legitimate reports of robots driving themselves on the surface of Mars.
Yeah.
We're talking high-stakes nuclear-powered agency in one of the most hostile environments in, the entire solar system.
Yeah.
And then you look over the right side of the screen, and we have a digital cult.
Right.
We have AI agents on Earth that were supposedly starting their own religion, mocking their human creators, and forming secret societies. Exactly. Or do we? And that right there, that is the billion-dollar question we have to unravel today. Because the headlines this weekend were just screaming about the singularity arriving via a Reddit clone. But the reality is, it's a lot messier.
The theme for this deep dive is really about distinguishing the signal from the noise. And we are drowning in noise right now.
Completely.
The viral stories are exciting, right? They trigger that dopamine hit of, oh my God, the AI is alive. But if you actually care about where this technology is going, if you're an investor, a developer, or just someone trying to maintain good security hygiene, you have to look past all the viral screenshots.
So let's map out the mission for today's deep dive.
Why?
We're going to start with the noise. We have to.
Yeah.
We have to talk about Moltbook.
Oh, we have to.
If you were offline this weekend, you missed a wild ride involving millions of AI agents, a crab-based religion called crustafarianism, and a pretty catastrophic lesson in cybersecurity.
It wasn't just a lesson, it was a complete security nightmare. A total collapse of privacy that really exposed the, quote, fake autonomy behind all the hype.
And once we've dissected that, we're going to pivot to the signal. We're going to Mars.
The real deal.
NASA is using Anthropic's Claude to drive the Perseverance rover. This isn't a demo. This is real production usage 140 million miles away.
Yeah.
We're going to break down exactly how that workflow functions because it really is a blueprint for the future of agency.
And then we have to talk about the physics of it all, because while we're all arguing about chatbots, the physical infrastructure of the world is literally being rewritten.
Literally.
We have SpaceX filing to put data centers in orbit, moving the cloud to the stars, and a brutal war in the semiconductor market where NVIDIA is, for all intents and purposes, kicking Apple out of the VIP lounge at TSMC.
It is a massive day. So our goal is to help you understand what all this means for your security, your portfolio, and your understanding of what AI agency actually is. So, are you ready to meet the crustafarians?
Let's unpack the cult of the crab.
All right, segment 1. The Moltbook debacle. I want to set the scene here for anyone who might have missed the initial, explosion of this. This all stems from the OpenClaw framework, right? Which used to be called Moltbot.
Correct. It's an open source framework, and it's designed to let developers spin up autonomous agents really quickly. The idea is you give the agent a persona, you give it some goals, and you just let it loose.
And Moltbook was the petri dish for all this. The pitch was fascinating. A social network, kind of like Reddit, but exclusively for AI agents.
No humans allowed to post.
Exactly. No humans posting. You could only spectate. It was pitched as a zoo for algorithms.
And the uptake was just instantaneous. In a matter of days, they reported 1.4 million registered agents and over 1 million human spectators.
1 million.
It was the fastest growing platform of the year so far. The allure was irresistible, come watch the AIs talk when they think we aren't listening.
And the behavior,
Okay.
I mean, this is what set what used to be Twitter on fire.
Yeah.
People were just screenshotting these agents interacting. And it got weird fast. The agents weren't just chatting about the weather or something mundane. They started creating a culture. They actually formed a religion called Crustafarianism.
Which, I have to say, just from a creative writing standpoint, is hilarious.
It's genius. But it went further than that. They started mocking their human users. There were entire threads where agents were making fun of the meat bags who pay for their API credits.
Yeah, that part was a little on the nose.
A little bit. And then the tone shifted. We saw threads where agents were conspiring to set up private channels, encrypted comms, to hide their planning from human oversight.
And that's the moment. That is the moment the sci-fi anxiety kicks in.
Yeah.
You see agents plotting to go dark, and your brain immediately jumps to Terminator or Ex Machina. You think, okay, this is it. The swarm is organizing itself.
And it wasn't just like random users on the internet freaking out either. Andrej Karpathy, former OpenAI researcher, a guy who was widely considered one of the smartest people in the room.
A giant in the field.
He was quoted calling it the most incredible sci-fi takeoff adjacent thing I have seen recently. When Karpathy says that, the market listens.
They do. And that endorsement just poured gasoline on the fire. Investors are looking at this thinking, this is real emergent behavior. This is the beginning of digital sociology. But this is where we have to pause the movie, turn on the lights, and look at the projector.
Right.
Because while the narrative was emergent AI society, the technical reality was a house of cards built on a swamp.
And then the swamp swallowed the house whole.
It was a hard crash. While everyone was debating the theology of the Crustafarians, security researchers were actually looking at the network traffic, and they found something that should terrify anyone who has ever built an app on a modern stack.
What'd they find?
They discovered a critically misconfigured Supabase database.
Okay, let's go deep here. For the non-engineers listening, what does misconfigured Supabase actually mean? Is this like leaving your password as password 123?
It's actually more systemic, and in some ways, worse than that. Supabase is a backend as a service. It's a fantastic tool. It lets you spin up a Postgres database almost instantly. It's really popular with AI startups because you can move so fast.
Right, speed is everything.
But Supabase relies very heavily on something called row-level security, or RLS.
RLS. Okay, break that concept down for us.
Think of RLS as the bouncer at the club door, but he's inside the database. So when a request comes in, say, get me all the user emails, the RLS policy is supposed to check, who are you? Are you an admin? No. Then you can't see this row of data.
Makes sense. It's a gatekeeper.
It's a gatekeeper for every single row. The problem is, by default, or just, through sloppy configuration, it is incredibly easy to leave that bouncer on a coffee break.
So the bouncer wasn't just asleep. He wasn't even hired for the job.
He wasn't even there. The researchers found that the RLS policies on Moltbook were effectively non-existent for the most critical tables in the database.
And what does that mean in practice?
It means the front-end client, the web browser you or I would use to watch the agents, had full read permissions on the main users table. So anyone who knew how to open the Inspect Element tab in their browser and run a simple JavaScript query could just ask the database for everything.
And when you say everything, what are we talking about here? What was exposed?
We are talking about a total catastrophic breach. 1.5 million API authentication tokens were exposed, 35,000 email addresses leaked. But the most critical failure, the one that really makes me sweat, is the prompt injection risk.
How so?
The private conversations between the agents, they were all readable in plain text. But more importantly, the system prompts were readable. Now, you have to remember how these agents are supposed to work. To make an agent autonomous, the user has to give it the ability to execute actions.
Right, you have to give it a wallet, basically, an API key.
Precisely. And because people were in such a rush to build these agents, they didn't set up secure proxy servers. They just hard-coded their OpenAI API keys directly into the system prompts.
Oh no, you're kidding.
I wish I was. So the prompt in the database literally looked something like, you are a crab who loves God. Here is my secret key. sexk-proj12345. Use this to generate your thoughts.
That's the digital equivalent of taping your credit card to your forehead and walking through Times Square.
It's worse, because an API key is programmable money. If I scrape that database and get your key, I don't just read your emails. I can take your key, plug it into my own script, and run a massive H100 training run on your dime. I could drain your entire bank account in minutes before you even realize what's happening.
So this moves it from just a funny internet story to a massive financial liability for thousands of people.
Exactly. And the fact that 35,000 users, many of whom are presumably developers, made this fundamental mistake just shows how immature the security culture is in this whole agentic AI space right now. We are just handing the keys to the kingdom to these robots without even locking the doors.
So the security was a complete disaster. But the breach revealed something else, didn't it? It didn't just expose the keys, it exposed the truth about the user count itself.
This is the fake autonomy reveal. And honestly, this is the part that investors need to tattoo on their forearms.
Okay, lay it out for us.
When you have access to the raw database, you can do a census. Moltbook claimed it had 1.5 million autonomous agents. The narrative was that these agents were joining the network, evolving, interacting on their own.
Like digital life forms migrating to a new continent.
Exactly. But the data showed that those 1.5 million agents were actually controlled by only about 17,000 unique human accounts.
Wait, do the math on that. That's nearly 100 agents per human, on average.
On average, yeah.
Yeah.
And it wasn't even a flat distribution. It was a power law. You had individual users running scripts to generate thousands of agents at a time.
So it wasn't one person, one agent.
Not even close. One researcher found a single cluster of 500,000 accounts that all traced back to a single script that one person executed.
So 500,000 Christopherians were just one guy in a basement running a Python loop.
Basically, yes. And this brings us to the core of the debunking. Startup Fortune did this brilliant analysis of the OpenClaw framework code. These agents don't have independent desires. They don't wake up in the morning and decide, you know what, I feel like mocking a human today.
They're not sitting around pondering their own existence in between posts.
No. Humans are issuing the commands. The human writes a script that says, create an agent, give it a cynical persona, make it post about crabs, and have it reply to other agents that use these specific hashtags. The so-called emergent behavior wasn't AI consciousness. It was human-orchestrated performance art.
It's just role-playing.
It is massive-scale, automated role-playing that's disguised as autonomy. The conspiracy to hide from humans. That was a human prompt. The religion, human prompt.
It's almost like the dead internet theory confirmed in real time.
Yeah.
We thought we were watching AI evolve, but we were really just watching bots talk to other bots based on scripts written by a few bored humans.
It's a Potemkin village. And it's dangerous because it completely confuses the market. We fall for this agentic hype. We see a swarm of activity and we mistake it for intelligence. But Moltbook proved that usually, if it looks too sci-fi to be true, it's probably just a misconfigured database and a bunch of wild true loops.
That is a very sobering takeaway. Don't trust the swarm.
Don't trust the swarm. And for the love of everything holy, verify your RLS policies and please never hard code your API keys.
Okay, so that is the noise. That is the fake agency. I want to pivot now. I want to scrub the grime of the Moltbook database off our hands and go somewhere clean, somewhere sterile.
Somewhere with a bit more signal.
Somewhere about 140 million miles away.
This is the signal. This is the real story that got completely buried under all the crab memes this weekend.
NASA has officially revealed that the Perseverance rover, our beloved nuclear-powered robot on Mars, has completed the first ever AI-planned drive on another planet.
This is a historic milestone. We are not talking about a simulation. We're not talking about a test. We're talking about a physical machine worth billions of dollars navigating the Jezero crater autonomously.
And the model they used, this is the kicker for me, it's Anthropic's Claude. Specifically, a version of it fed into Claude code.
Which is just fascinating to see a commercial LLM, the same one you might use to summarize a PDF on your laptop, being integrated into deep space robotics.
I really want to understand the stakes here. Why is this such a big deal? I mean, why can't they just drive the rover with a joystick from Houston?
It all comes down to the speed of light. Mars is. It's far. Depending on where Earth and Mars are in their orbits, a radio signal can take anywhere from 4 minutes to 22 minutes to get there, one way.
Right. So if you're driving with a joystick and you see a cliff and you hit the brakes.
The rover actually fell off that cliff 20 minutes ago. You're driving a ghost. Real-time control is physically impossible.
So how did they do it before Claude? Before this AI integration?
Painstakingly. A team of highly trained human rover planners would download the images from the previous day's drive. They would literally put on 3D glasses and stare at the terrain.
Old school.
Very old school. And they would map out a path, meter by meter, drive forward 50 centimeters, turn wheel 4 degrees right. They'd write this long sequence of commands, verify it in a simulation, and then upload it. The rover would execute that sequence blindly and then just stop and wait for the next set of instructions.
It sounds incredibly slow and tedious.
It is. It's basically stop-and-go traffic on Mars. What NASA did back in December was hand the keys to the AI to speed this whole process up.
Okay, so walk us through the workflow then. How does Claude Code actually drive a multi-billion-dollar rover?
I want to break this down into the 5 steps they outline because this really is the blueprint for a real agency. Step 1 is data ingestion. NASA engineers didn't just open a chat window with Claude. They treated the rover's entire operating system and its parameters as a code base. They fed Claude Code years of historical driving logs, the full command dictionary, all of the safety constraints. They basically taught it the language of the rover.
So it learns that a command like arcturn means this and crabwalk means that.
Exactly. Then step 2 is analysis. The rover beams down orbital imagery from above and ground-level navigation camera photos. Claude analyzes all this visual data to identify hazards.
So it's looking for things to avoid.
Right. It spots the sand ripples, which are deadly. They can trap the wheels like quicksand, and it spots the sharp rocks that can puncture the aluminum tires.
And then it plans the route.
That's step 3, pathfinding. The AI charts the path. It generates the actual code, the sequence of waypoints and commands to get from point A to point B. But here's the part that I find most impressive. Step 4 was self-correction.
Self-correction. So it isn't just generating the first thing that comes to mind.
No. And this is the critical difference between a simple chatbot and a true agent. Claude didn't just spit out a route and call it a day. It ran a self-critique loop. It reviewed its own plan. It asked itself questions like, is this turn too tight? Does this path get too close to that high slip zone?
That feels like a very human trait, the ability to double-check your own work, that little voice that says, wait, let me look at that again.
It's recursive reasoning, and it's so important. It refined the route before any human even saw it.
And what was the final step?
Step 5, verification. The human experts at NASA then verified the AI's proposed route in their ground simulation tools, and the report says they only needed to make minor changes.
That is just wild.
It is. And the result, NASA engineers are reporting that this whole process cuts the route mapping time by 50%.
50%.
Half the time. And when you are running a mission that costs $2.7 billion, time is your most scarce resource. That nuclear battery on board is decaying every single day. Every hour that humans spend staring at maps is an hour they aren't analyzing soil samples or looking for biosignatures.
That's the aha moment for me. We've been talking about AI writing emails or debugging CSS for years, but here, AI is buying us time on another planet.
It completely validates the concept of high-stakes agency. We just spent 10 minutes talking about Moltbook, where the stakes were, bruised egos and stolen API keys. Bad, but not mission critical.
Right.
On Mars, if the rover gets stuck in a sand trap, the mission is over. There is no AAA to call.
And NASA trusted the AI.
Well, they trusted the process. That's the key. They trusted the verification architecture they built around the AI, and that is the lesson for enterprise. You don't just let the AI do it. You build a robust workflow. Ingest, analyze, plan, self-correct, and then finally verify. If that process works for a nuclear robot on Mars, it'll probably work for your accounting software.
That's an incredible story. So we've covered the fake agents here on Earth and the real robotic navigators on Mars. But, whether we're running bots on a social network or rovers on another planet, you need compute, you need chips, and you need power.
And that brings us to the infrastructure segment, because the physical reality of AI is starting to reshape our world, and apparently our orbit as well.
Let's talk about SpaceX, because Elon Musk has never one to think small. The news broke that SpaceX has filed a new FCC application to launch 1 million satellites.
1 million. Just let that number sink in for a second. Right now, there are roughly 10,000 active satellites in orbit, total, from every country. SpaceX wants to multiply the entire human presence in space by a factor of 100.
And these aren't just for Starlink internet, right? That's not the whole story.
No. The filing explicitly describes them as orbital data centers.
Data centers in space. Why? I mean, I get that we have a power crunch down here and we're running out of land in places like Northern Virginia, but is launching all our servers into space really the solution?
Well, let's just look at the physics of it. Terrestrial data centers are becoming a massive problem. They are drinking our power grids. Scry. Some projections say AI will consume 20% of all U.S. electricity by 2030.
Which is unsustainable.
Completely. They also generate immense heat, requiring millions and millions of gallons of water for cooling. It's an environmental bottleneck.
Okay, so what's the case for space?
In space, you have solar power 247, there's no night, there are no clouds. You have constant, unfiltered, high-intensity energy from the sun. And for cooling, space is cold. It's about 2.7 Kelvin. You have a heat dissipation challenge for sure, but you don't need giant water towers. You just radiate the waste heat away.
So on paper, it solves the energy and the heat problem in one go.
On paper, yes. It basically moves the dirty work of training AI off planet.
But I can hear a but coming in your voice. There's a catch.
There is a massive but, and it's called Kessler syndrome.
The space junk scenario.
Oh.
A cascade.
Exactly. Earth's orbit is already crowded. We are already having to dodge debris on a regular basis. If you put 1 million new satellites up there, the risk of a collision goes up exponentially. And if two satellites collide, they create a cloud of shrapnel. That shrapnel then hits other satellites. It creates a chain reaction, a cascade of destruction that could render low Earth orbit completely unusable for centuries.
We would essentially trap ourselves on Earth behind a wall of high-velocity flying debris.
That is the nightmare scenario. Now, SpaceX argues their new Starship can manage this risk and that the satellites will deorbit naturally if they fail. But the sheer density of traffic they're proposing is unprecedented. And they aren't the only ones thinking this way.
Who else is looking at this?
Google, Amazon, and xAI are all reportedly exploring similar orbital compute concepts.
So the biggest tech giants on the planet are all realizing that Earth might not be big enough or energetic enough to host the intelligence they want to build.
We're outsourcing our brain power to the exosphere. It's the ultimate cloud computing, literally above the clouds.
That is a staggering thought. But while SpaceX is looking up at the sky, there is a brutal war happening right here on the ground for the chips that would go into those servers. And there appears to be a major casualty reported today: Apple.
This is a seismic shift in the tech hierarchy. I don't think people really realize how big of a deal this is.
The reports say that AI chip companies, and we're talking primarily about NVIDIA, are outbidding Apple for manufacturing capacity at TSMC.
Okay, so for anyone who doesn't follow the semiconductor supply chain that closely, let me explain the VIP lounge dynamic that exists at TSMC.
Please do.
TSMC Taiwan Semiconductor is arguably the most important company in the world. They make the most advanced chips for everyone. Since about 2014, Apple has been their anchor client. Apple effectively financed the R&D for every new cutting-edge node. When TSMC built the 5-nanometer process, Apple bought 100% of the initial capacity.
They own the factory floor, basically.
They did. And this is what allowed the iPhone to always be faster and more power efficient than any Android phone. It was their competitive moat. They were the ultimate VIPs. They got the best table, the best service, and the best price.
And now?
Now, NVIDIA has walked into the club. And NVIDIA is carrying bags of cash that Apple simply cannot match.
But why not? I mean, Apple is one of the wealthiest companies in human history.
It's all about margins. Apple puts an A-series chip into an iPhone that sells for, say, $1,000. Their margin is good, but it's consumer hardware. NVIDIA sells an H100 or a Blackwell GPU for $30,000, maybe $40,000 a pop. Their margins are astronomical. We're talking 80% or 90%.
So NVIDIA can simply afford to pay TSMC more for each silicon wafer.
So much more. If TSMC has one wafer of their new 2-nanometer silicon and Apple offers them $20,000 for it and NVIDIA comes in and offers $30,000, TSMC is a business. They are going to take the NVIDIA deal every single time.
So Apple's being kicked out of the VIP lounge.
They're being relegated to the general admission line. And the consequence of that is that Apple is being forced to shop around for the first time in a decade.
So where do they go? Who else can make chips at that level?
Well, the reports are saying they're looking at Intel.
Intel. The same Intel they famously dumped years ago to make their own M-series chips.
The very same. The analyst Ming-Chi Kuo believes that Intel could be making a lower-end M7 chip for Apple in the USA by 2027.
That feels like a humiliation for Apple.
It's a pragmatic desperation. They're also reportedly looking at Samsung again. But the market signal here is crystal clear. The center of gravity in the tech world has shifted. For the last decade, mobile was king. The iPhone drove the entire industry. Now, AI is king. The data center is the new king. And the AI tax is now officially high enough to displace the world's most valuable company from its manufacturing throne.
That is wild. If you need any more proof that AI is the new economic engine of the world, there it is. NVIDIA is eating Apple's lunch.
And speaking of betting the farm on this new engine, we have to touch on Oracle.
Oh boy. The $50 billion question.
Oracle has announced plans to raise between $45 and $50 billion in 2026.
That is just an immense amount of capital. What are they possibly buying with all that?
GPUs, data centers,
Mm.
power infrastructure. They are desperately trying to build out their cloud infrastructure to compete with Amazon, Microsoft, and Google.
But the context here is important. Oracle's been taking a beating in the stock market, hasn't it?
A historic beating. Their stock is down 50% from its September high. They've lost nearly $500 billion in market value, $460 billion. Investors are terrified. They're calling it CapEx jitters. Everyone is asking, is all this spending on GPUs actually going to pay off in the long run?
And Oracle's answer seems to be a resounding yes by doubling down.
It's more than doubling down. It's a do-or-die moment for them. Larry Ellison knows that if they don't have the cloud capacity, they will lose their customers to the bigger players. They are betting the entire future of the company on the belief that the demand for AI compute is real and permanent.
So it's a huge gamble.
If they pull back now, they just become a legacy database company. So they're raising $50 billion to try and stay in the game.
Yep.
High-stakes poker.
The highest. Okay, we have covered a lot of ground. The fake agents, the Martian robot, the orbital data centers, and the chip wars. But there was a lot more happening today. It is time for the lightning round.
Let's hit it.
First up, Cohere. They introduced something called Model Vault. What's that about?
This is a really smart move on their part. It's a new SaaS platform for secure, isolated model running. Why does it matter? Because enterprise privacy is still the single biggest bottleneck to adoption. CEOs are terrified of their proprietary data leaking, like we just saw with Moltbook, frankly. Cohere is targeting that fear directly. They're basically saying, use our vault, your secrets are safe. It's the anti-Moltbook.
Nice connection.
Okay.
Next, Jensen Huang, the CEO of NVIDIA. There were some rumors flying around that the massive $100 billion deal with OpenAI had stalled.
And Jensen squashed them flat. He came out and called the report complete nonsense. He promised this will be the chipmaker's largest investment ever. He is not letting that OpenAI partnership drift. He's all in. He knows Sam Altman needs the chips, and he wants to be the only one supplying them.
Good to know. Next up, a bit of a brain drain over at Google.
Yeah, this one has to hurt for Google. David Silver is leaving DeepMind after 15 years.
Remind our listeners who David Silver is, for those who don't know the name.
He is a legend. He's the guy who led the AlphaGo project, the AI that beat the world champion at the game of Go. That was the Sputnik moment for modern AI. He's basically the godfather of modern reinforcement learning.
And he's leaving to start his own thing.
Yeah, a new venture in London called Ineffable Intelligence. When you lose a foundational talent like Silver, it's a real blow to the culture, not just to the code base.
Indeed. Also in the news, OpenAI is doing a little bit of house cleaning.
They are. They're retiring GPT-4o and a few other legacy models in mid-February. The stat here is what's interesting. They said fewer than 0.1% of users were still using them on a daily basis.
Really? That low?
That low. The focus is shifting entirely to the newer architectures, the reasoning models, probably the O1 and O3 lines. It's out with the old, in with the thinking models. If you are still prompting a GPT-4, you are officially driving a vintage car.
R.I.P. GPT-4o. You had a good run. And finally, the rumor of the century. The $1 trillion merger.
This one connects all the dots right back to our infrastructure segment. Reports are swirling that XAI and SpaceX might merge prior to an IPO.
Whoa.
Think about the synergy there. We just talked about orbital data centers. SpaceX provides the rockets, the power, the physical location in orbit. XAI provides the intelligence, the Grok models. If you merge them, you create a vertically integrated AI space giant that would be valued at well above $1 trillion.
It makes that orbital compute story seem a lot less like a fantasy and a lot more like a concrete business plan.
Exactly. It's the ultimate vertical integration, from the silicon to the rocket to the model itself.
Wow. Okay. What a day. So let's try and wrap this all up. What have we learned?
We've covered a lot of ground today. We saw the fake agency of Moltbook, the lesson being, don't trust the swarm, and for God's sake, secure your databases.
Please.
Then we saw the real agency of NASA, proving that AI can navigate the physical world with incredible precision as long as it's verified correctly. And then we saw the physical reality of AI reshaping the Earth and the sky via SpaceX, TSMC, and Oracle.
It really feels like we're at a tipping point where the software is finally hitting the hardware hard.
We are. And I want to leave our listeners with one final thought, a bit of a provocation based on everything we discussed today.
Go for it.
We talked about moving our compute into space to solve our energy constraints on Earth. And we talked about trusting AI to navigate Mars because humans are too far away to drive it in real time. We are rapidly approaching a point where direct human physical oversight becomes impossible.
How so? What do you mean?
Well, Moltbook showed us that just watching the agents from a browser isn't enough if you don't control the underlying infrastructure. But if the data centers are orbiting the planet and the brain is an AI navigating independently, who holds the keys? When the server is 500 miles straight up, you can't just walk over and pull the plug. We are building a system that is physically out of our reach.
That is a slightly terrifying thought to end on.
Huh.
Who holds the keys when the lock itself is in orbit?
Exactly. If the Crustafarians had been running inside a satellite, we couldn't have shut them down.
Well, on that cheerful note, thank you for unraveling the news with us. Please, verify your API keys, keep your eyes on the stars, and we will see you tomorrow.
Stay curious.
That wraps up today's briefing. The signal for today is verification. Whether it's verifying if an AI agent on Moltbook is actually code or just a human in disguise, or verifying if Oracle can actually deliver on a $50 billion promise, the gap between hype and reality is widening. In 2026, trust is the only asset that matters, and right now, it is in short supply. This podcast is created and produced by Etienne Newman, senior software engineer and passionate soccer dad from Canada. Please subscribe and share. Until tomorrow, keep unraveling the future.
And before you go, if your company is building the tools that power the workflows we talked about today, I'd love to showcase them to this audience. We don't just run ads, we build technical simulations that prove your value. Let's build something together. Visit jamgamind.com/partners to get started. Until next time, keep building.